The Weekly, hosted by the editors of Pro Builder and Pro Remodeler, starts now. I'm here with Patti Gunderson, who is a building science engineer at Home Innovation Research Labs in Maryland. Welcome, Patti.
Hi, nice to be here.
It's great to have you here, and I wanted to bring you on because you were an integral part of a new wall system that you worked with with a number of different folks, and that we covered in a recent issue of Pro Builder. And I thought, given the reaction that we got to that story and when we posted it on our social media channels, that we should get you on and just have you talk to our audience about that system. So before we jump into that, though, why don't you just give me a little background on you and what you do at HI and specifically for this project?
You bet. So Home Innovation Research Labs, some of your viewers may actually know us by our old name, which is the NAHB Research Center. We are a wholly owned subsidiary of the National Association of Home Builders, but we are completely independent. And so when we do research for them, we write up a contract and perform in just the way that we would for any other client. In my particular division, which is building science, we typically work for government programs, very often DOE. We are, for instance, a longstanding member of the Building America team. And so we typically are performing on contracts for the Department of Energy, maybe 1 or 2 or 3 at a time and with staggered starts. And we also work for other industry clients and professional organizations that have a vested interest in the construction industry, and even other states that have large programs. For instance, NYSERDA has a huge energy research program. So I've been at Home Innovation for about 5 years now, and prior to that, I worked as a design engineer on big construction projects, mostly commercial, and often very low energy, a lot of net zero, a lot of living building challenge projects. So it was really exciting for me to get an offer from Home Innovation to come and focus my time on energy.
Okay, great. Thank you for that. So what we're going to be talking about is the extended plate and beam system that you and others came up with and tested at HI, and then but now it's called something else, called the extended plate wall, correct? So
right. Yeah, over the course of the last year, we conducted an effort to try to get it approved in the IRC, the International Residential Code, and for simplicity, we changed the name to the EPW, extended plate wall. The beam is not an integral component. It happens to be able to the construction happens to be able to perform a beam mechanism, but it's not an important aspect of the code proposal, and so we just wanted to simplify.
All right, so let's get into it. So let's just kind of talk about what EPW is, and we've got some graphics here to kind of show folks.
Oh, yeah, great.
You know what the kind of the components of the assembly, and then just kind of walk us through kind of what it is.
Sure. So for maybe 2 decades or more, high-performance builders have tended to use a rigid foam insulation layer to the exterior of the sheathing, and it's been a really wonderful solution to improve R value and even to provide some nice aspects having to do with moisture durability and air barrier protections. However, in the course of that 2 decades or so, it's pretty much been adopted by the cohort of builders that were willing to adopt it. In other words, it got to something like 5%, maybe at its highest adoption rate was around 10%, and then it sort of stalled. And that seems to be because there are some complexities associated with applying that exterior layer of rigid foam that just kind of befuddle the typical builder. It's not that they can't solve it, but they're in a hurry and they have to maximize and optimize all their efforts. And it's a little bit too different from standard lumber framing. As most of your viewers know, when you put an exterior layer of foam on the outside of a house and over the sheathing, there are a couple of problems. One is now you're applying siding directly onto the face of the foam. You're attaching windows with the flange directly on the face of the foam. And for some people, they find that a little bit uncomfortable. The real difference in the application of the foam and the WSP, in this case for the extended plate wall, is that we've got the WSP on the outside and the foam on the inside. We still have typical lumber framing, but in order to make the attachment, we actually use 2x4 studs. And at the top and the bottom, we use plates that are 2x6. So you can imagine in a profile that leaves a little space here, so plates at the top and the bottom, and a little space here that happens to be with 2x6 and 2x4s, exactly a 2-inch thickness. And foam comes in 2 inches. So you can get mineral wool, you can get rigid foam, EPS, XPS, polyisocyanurate, all of those are available in 2-inch thicknesses. And so that's an opportunity to use the foam that comes directly from industry and mold it to this wall system. And then with those plates at the top and the bottom, we nail directly through the OSB or the plywood to those plates, top and bottom. And then at the studs, we're still connecting with the framing, but of course it's just connecting through that 2-inch layer of foam. So it does use a longer nail than framers are sometimes familiar with, but there are several nail guns available in the construction industry that will shoot a nail like that. And so you can pretty much follow all your typical practices. We have 4 different demonstration homes all over, 2 in Grand Rapids, 1 in New York, and 1 in Pennsylvania. So we've got a lot of different climate zones covered. We've worked with 3 different builders. It was the same builder for the 2 in Grand Rapids, Michigan. And one of the 4 was actually factory panelized. So that proved like a secondary opportunity for this wall system. To produce a panel in a factory like that where the rigid foam is exposed means that it's not just hard to build it, but it's really hard to pack and ship it and store it on site. That foam is very vulnerable. But when we've got the OSB on the outside, that protects it through all levels of the process so that when it gets to the job site, it can just be tipped up into place.
Okay, that's great. Yeah, that was an interesting aspect that I found when we researched the story. Was that it has this factory aspect that really protects the panel from being as it's being transported. So, talk to us a little bit about code compliance, because I know builders are always nervous about that when innovations come out, even if it's something that seems really logical and simple, relatively simple in this case. But talk to me about code compliance and where you are there.
So right now, people can build these walls, but it is an engineered solution. So you would have to have somebody on staff or somebody that you know of with a structural PE who is willing to take a look at our design values that were developed in our lab and use those design values to produce actual drawings. There's really nothing unusual about it. This wall performs as good or better than any 2x4 framed wall or 2x6 framed wall for 2 stories and less. And it provides excellent thermal benefits and some real advantages in terms of the construction and the moisture performance. So there's no reason for it not to be adopted, but because it is a fairly new methodology, it didn't quite pass muster this time, but we expect to present it again next time around. Of the 4 projects that we did, not one of them required a PE stamp because there is always a local option. And in all 3 cases, the local authority said, that makes sense to me. I don't see that there's enough difference. We had design values to share, and the local AHJ accepted it. So I don't want everybody to think that the only way that they could do it is with a stamped drawing. But it may be that in your local jurisdiction, they're just a little more cautious, and that's quite reasonable. And in that case, you would want to go get an engineered design.
Right. That's a great point to make. Thank you. So one of the things that builders, and maybe you've heard this, I know we heard it in some of the comments that we got back on the article, what had to do with cost, that was perceived as a cost premium. And again, that didn't make a lot of sense to me because you're using the same materials just in a different sequence.
Sure.
So how do you kind of address that if you've had to address that?
When we compare to a wall with 2 inches of foam that's completely exterior installed, we find that the cost of the extra effort in constructing it in the different sequence, kind of learning that new method, is not a real heavy lift, and it's easily made up by the fact that when you get to the point of installing cladding, installing the WRB, and insetting windows, all of a sudden it goes way faster than a wall that has exterior foam on the outside because you have that nailing surface. And framing crews and cladding crews tend to be much more familiar with having that OSB be the surface that they're working with. You have to realize too that as the code progresses, now we're at 2020, that exterior layer may be eventually required for all jurisdictions. So there's a large cohort of builders out there who really haven't touched the exterior foam at all. And if they can leapfrog the exterior sort of wrapping a house in foam and go straight to the extended plate wall, that may kind of ease the transition for them. It might be a little less difficult to teach up your framing crews to do it, and especially the opportunity to have the walls panelized in a factory could be the difference to allow them to bring in higher thermal value at pretty much the same cost.
Well, Patti, thanks again for your time. I appreciate your time and your insight. This has been great.
Super. I appreciate the interest from you folks. And we don't have any ongoing research about the extended plate wall right now. We've done a ton in the past, and so we have all those resources on our website. And for anybody who wants to jump into it, we would be happy to answer questions or help guide you along. But I think you'll find what you need in one of the 2 construction guides that we've got posted online, and there's lots of resources there.